Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids. Math, science, history, unraveling the mystery that all started with a big bang. Hey! Since the dawn of man is really not that long, as every galaxy was formed in less time than it takes to sing this song. A fraction of a second and the elements were made.
Atom, the smallest unique form of matter, what everything is made of. While the model has changed over the years, the atom has always been the same. The history of the atomic model can be traced back to ancient Greece, where the philosopher Democritus, around the year 400 BC, asked the question, could matter be divided into small pieces forever, or is there a limit to the number of times it can be divided? He thought that matter eventually reached a point where it could not longer be cut, and the term atomos appeared, indivisible. He described it as invisible spheres of matter, all identical and infinite. "2,000 years later, in 1803 AC, the British scientist John Dalton came up with his model of the atom. He formalized Democritus's model with various ideas. He said that all matter is composed of atoms, atoms cannot be created, divided, or destroyed, all atoms of an element are identical, chemical reactions combine or separate atoms in whole number radius. The discovery of subatomic particles disproves that indivisibility of atoms, and isotopes disprove that all atoms of an element are identical. Then, in 1897, Joseph John Thompson came up with his plum pudding model, named this because of the resemblance to the dessert. After performing his cathode ray experiment, he discovered electrons. Unlike Dalton's model, the plum pudding model showed the first internal structure. The whole atom is positively charged, while there are electrons with negative charge floating inside. There was still no nucleus, and he incorrectly predicted the positive charge distribution. In 1912, a man called Ernest Rutherford conducted the gold foil experiment and found out that the atom is mostly empty space and that it has a positive charged core, which he called the nucleus. This is where he discovered the proton. Later, James Chadwick discovered that there was something that prevented electrons and protons from coming together, the neutron. This model has no specific orbits for the electrons. A year later, the physicist Nicolás Bohr proposed his model that contained special circular orbits for the electrons around the nucleus, divided by energy levels. This model is used nowadays to teach because it is simple to learn and has clear representations of each electron shell and the nucleus. It was the first model to use quantization. This model does not portray the new findings. After the 1930s, the wave model was proposed. This model is based on wave mechanics, where electrons do not move in a definite path. There is only a probable place where electrons may be located, but not certain. It is mostly a mathematical model, very difficult to grasp and to study at high school levels. The atomic model helps represent the most basic unique structure of matter, what everything is made of. It also helps us understand what makes each element, isotope, and ion different, and how and why chemical reactions happen. It is a simple graphical representation which helps people understand a very complex, microscopic structure only found with advanced mathematics.